Hi, welcome to the screencast on using Mathematica's built-in root finder. Finding roots numerically can be very useful when an expression that you obtain has multiple roots, when you're trying to solve a transcendental equation, or if you're trying to find when a complicated expression goes to zero. We're going to get started with a really simple example. X plus 2 times x minus 2 equals 0. We're going to try to find those roots numerically. First, we're going to plot that function x plus 2 times x minus 2. And we'll go ahead and plot it from minus 5 to 5 so we can see the roots very clearly. So those roots are minus 2 and plus 2 as we'd expect, and there's a minimum at 0. Now we're going to try to determine those roots numerically using Mathematica's built-in root finder, FindRoot. The first thing that the root finder expects is the function for which you're trying to find the root. So in this case it's x plus 2 times x minus 2. Now we can be very precise and we can say that that has to be equal to 0, but in fact if you leave that off, the root finder actually automatically says this function has to be equal to 0. So you can leave that off or you can keep it in, it doesn't matter. The next thing that it expects in parentheses are the variable which you're looking for and a guess for that root. So the variable is going to be x, and the guess, well, that we need a little bit more information about how Mathematica determines roots. So it actually uses an algorithm which is sort of broadly called bracketing the root. Essentially, you give it a starting guess, let's say over here on the right side, and Mathematica computes the value of the function at that point, which would be negative. Then it creeps along until it finds sort of a positive one. It takes another guess, essentially, and it finds a positive value. Then it goes back and forth, computing closer and closer values, which are smaller and smaller in terms of their actual value, until it gets pretty darn close to 0. So that's just called bracketing the root. It's a pretty broad algorithm. It turns out that that algorithm breaks down if your guess is a minimum or a maximum of the function. And we'll see how Mathematica handles that. So we're going to go ahead and give it the guess of 0. And it turns out that it gives you this error in which it suggests, why don't you perturb the initial point a little bit? So why don't you kick it a little bit to the right or the left, because I can't find any value lower than that value. So we'll give it a very, very, very small value just to the right, and it turns out Mathematica finds the root on the right-hand side pretty easily. Now, it's determining this root numerically, so I'm going to go ahead and just delete this really quickly, and you'll see that, in fact, it didn't find the value of 2. It found the value of 2 plus 2 times 10 to the minus 15. That's really just machine precision there. So again, it's determining this numerically, so it's going to have a little bit of numerical error associated with that algorithm. Let's go ahead and just copy this, and we'll paste it below here, and we'll just change the sign, and Mathematica will find the root on the other side, the root on the left side. Okay? So that's all pretty simple. Let's try and find the root of a transcendental equation, like x equals cosine of x. So to get a good guess, we should plot that function. So we're going to plot x minus cosine of x. And in this case, we're going to plot it from x equals minus 1 to 1. That turns out to actually show the root pretty nicely. So the root of this equation, if you look, is around 0.7 or 0.8. So we'll go ahead and call FindRoot now. And this time, I'm going to use the double equals syntax. So I'll say x equals cosine of x. And I'm going to go ahead and give it the guess of 0.7. So Mathematica numerically determines that root to be about 0.73908, which is looks pretty darn close to what the figure says. So we could have also replaced this with x minus cosine of x, and we would have gotten the same root. Mathematica's root finder is pretty robust. It can do a number of other things, including finding simultaneous roots and so forth, so it's worth checking out the documentation on FindRoot. This concludes the screencast on Mathematica's built-in root finder. Thanks for your time.